Using Newton's method of interpolation, find from the data given below the group between 20 and 25. So until now they asked us only one number. Now they will give us the class interval like this, which is open-ended class interval, and they are asking a closed-ended class interval. So if you see the previous questions, so they had given us closed-ended class intervals. Here you have 20, upper limit, lower limit, both is mentioned, and they had asked us less than, correct? So how do we solve such problems? We are going to see today. So let us start. So the first step is writing down the data given to us in the tabular format. Now that will remain same. We are not going to change how we write it. Solution. So first one assuming it as x, and then the second one assuming it as y. So here x and then y. Okay, and then you'll have leading differences that you'll have to find out. Okay, let's just write it as leading differences, and then we'll see how many differences we'll have to find. Okay, now x and y, however it is given, just write down like that. Okay, so if you see here, less than 10, okay, less than 10, less than 20, less than, I don't have space, that's why I'm writing L and T. Okay, you are expected to write the full name less than. Okay, less than 40, less than 50. Now in the next column you are supposed to write 20, 45, 115, 210, 325. So remember one thing, in the problems like this, if you see the closed-ended class interval where you have upper limit and lower limit, this will be the frequencies where we have found out cumulative frequency. Now, how did you get this 73? 42 plus 31. Then 73 plus 51. Correct? We have added the frequencies that is given to us. 31 plus 42 is 73. 73 plus 51 is 124. 124 plus 35 is 159. 159 plus 31 is 190. Right? But in the question that we are solving now, it is an open-ended class interval. Okay. Let's continue. So in this problem, since it is an open-end class interval, we have to just take the frequencies as it is, because these frequencies are already cumulative frequency. So if you see here, 20, it's in the increasing order. 20, 45, 115, 210, 325. So this is already a cumulative frequency. This is already a cumulative frequency. Okay, so that is the main reason we just take whatever number that is given to us when it is an open-ended class interval. Is that clear? Now let us find out the leading differences. The first leading differences will be between 45 and 20. So 45 minus 20 will give us how much? 25. Next, 115 minus 45 is 70. Then 210 minus 115 is 95. Then 325 minus 210, 115. So these are our first leading differences. Now the second leading difference is between these two. So 70 minus 25, 70 minus 25 will give me 45. 95 minus 70 is 25. Then 115 minus 95 is 20. Okay, so this is 25. This is equals to. Then third leading difference, until you get one leading difference, you're supposed to find the values. So here it's going to be 25 minus 45. So you'll get a minus value. Okay. So 25 minus 45, I'll write it below. It will be minus 20. And then 20 minus 25, it's going to be minus 5. And finally, the fourth leading difference, minus 20 minus minus 20 minus 5 will give you 15. Sorry, minus of minus 5 it is. Minus of minus 5. So that will give you 15. So we have got all the leading difference. Now only change in such problems that you have to understand is to write down the data which is given as it is. But in the problems of this sort, we will be adding the frequencies here. So if you want, you can just write a note in the previous problem that we solved saying note frequencies are given normal and we have to find cumulative frequency. Okay. And when it comes to this problem, you can write a note here saying since the given data is open-ended class interval, therefore we shall consider the cumulative frequencies as it is. Did you all understand until here? Any doubts? Okay. Now, the next step is to calculate x and then do our as usual calculation. Okay, let's start. Now we have to calculate x. Now x, what is the formula that is there? Firstly, you have to consider whatever is asked to find out. So the value of x to be interpolated. Now if you see this problem, what is the first and the last data? The value to be interpolated is between 20 and 25. So in such cases where you have two data given, consider the biggest number. 20 is small. So consider the biggest number 25. So here we will be taking x to be interpolated will be 25 minus x, the value of x at the origin. The value of x at the origin is what? It is 10. And the difference between the adjoining x values is also 10. See, 10, 20, 30, 40. There is a difference of 10 everywhere. So 25 minus 10, because 10 is at the origin, divided by 10 because 10 is the difference. So 25 minus 10 is 15 by 10, which is 1.5. So the value of x is 15. Clear? Sorry, 1.5, not 15. 1.5 is the value. So that is the x value. Now let us write down the formula and solve the problem. So when you write the formula, that is yx is equal to, first will be y0 plus x into leading difference, x into first leading difference plus x into x minus 1 into x, sorry, that's all. X into x minus 1 is the first case, divided by 2 factorial into second leading difference plus x into x minus 1 into x minus 2 divided by 3 factorial into third leading difference plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into fourth leading difference. I hope you know to solve this part. Let us start solving it quickly. So y0 is this value here, 20. 20 is the y0. Okay, we forgot to write those values. So y0, y1, y2, y3, y4. So y0 is 20. So let us write down that value here, which is equal to 20 plus x is 1.5 into first leading difference. First leading difference is 25. 25 plus, that's all right. Now second is x, that is 1.5 into 1.5 minus 1 divided by 2 factorial, that is 2, I will write 2 factorial only, into the leading second leading difference, which is 45 plus 1.5 into 1.5 minus 1. Okay, there's a lot of dots today. 1.5 minus 1 into 1.5 minus 2 divided by 3 factorial into, I'll write it here, continue here, okay, minus 20 is the third leading difference plus 1.5 into 1.5 minus 1 into 1.5 minus 2 into 1.5 minus 3 divided by 4 factorial into the fourth leading differences 15. Now let us solve this. 20 plus 1.5 into 25 will give you 37.5. 1.5 into 25. So you get 37.5 plus 1.5 into 0.5 divided by 2 into 1 into 45 plus 1.5 into 0.5 into 1.5 minus 2 is minus 0.5. 1.5 minus 2 is minus 0.5 divided by 3 into 2 into 1 into minus 20 plus 1.5 into 0.5 into minus 0.5 into minus 1.5 divided by 4 into 3 into 2 into 1 into 15. Show each and every step calculations. I don't want you to skip any calculation in between. Now 20 plus 37.5 plus, now let us do the next calculation. So here 1.5 into 0.5 is 0.75 divided by 2 will give you 0.375. Multiply that with 45, you get 16.875. Okay, then that is one. Now the next one, 1.5 into 0.5 into, sorry, into 0.5, that is minus 0.5, will give you minus 0.375 divided by 3 twos are 6. So divided by 6 into minus 20. So you get plus 1.25. And finally, see, you should do the calculation like this, or if you want to show steps in that also, you can show. There's no problem. 1.5 into 0.5 into 0.5, that is minus 0.5 into minus 1.5 will give you 0.5625 divided by 4 threes are 12, 12 twos are 24. So divided by 24, 0.023437 you'll get. Multiply that with 15. So what do you get here is 0.3515625. Now add everything. 20 plus 37.5 plus 16.875 plus 1.25 plus 0.3515625 will give you 75.9765. So I'll make it as 98. Okay, you get y as, you get yx as 75.98. Okay, so this is the calculation part. Now, any doubts in the calculation part firstly? Is the calculation clear? Any doubts in this? Good. Now coming to the conclusion. Now conclusion differs a little when you are giving here. Now usually what we used to do, they used to ask us one value and we used to say the number of students, the number of runs, whatever they've asked, we used to say the direct answer. But here they have asked the data, the question says we have to find the data given for the group of 20 to 25. It says for the group. So let us see how to write the conclusion for that. Now, the number of persons between the income group of 20 to 25. That's what is asked in the question. Okay. So how do we know what is the answer? To find this answer, now see here. Less than 25. We found it for 25. We took the number as 25 here and we found it. So which means we have found the number for less than 25. Okay. Now less than 25, we have found the number to be 75.98. This one. For less than 25, we found 75.98. Minus less than 20. Now from where do we get less than 20? Go back to the question. See here. Less than 20. Less than 20, what is the value? 45. Okay. So we have found until from 0 to less than 25, we have found the value to be 75.98. Okay. From 0 to 25, we have found out it to be 75.98. Now from this, if you minus 20, then the result will be 20 to 25. Okay. Another way of understanding this is through the timeline. Now from 0 to 25, we have understood there is 75.8. Now, if you write down the value from 0 to 20, if 0 to 20 is 45, if you take the difference between these two, you will be able to understand what is the value you have got here. Did you people understand the logic? How to find the value when the group is asked? Yes. So less than 20 is 45. 45 is the value here. So the difference will be 30.98. So the for the group it is, I'll round it off and write it as 31. So this is our answer. Did you all understand this, or you want me to repeat the conclusion part? Everybody understood? Compulsory question will come, so please don't take chance. It's a very easy answer. Okay, it doesn't consume a lot of time. Actually, your paper, if you write it properly, you can finish it before 2 hours. Okay, so only that thing which will take you time, maybe analyzing the question. So you'll have to practice. Only when you practice, you'll be able to do the things better. Clear, right? Okay. Now the next type of question, up to. Up to is the next type of question. Now we solved direct values. Now we solved open-ended class interval with less than. Okay. Now this is the next type of problem. The workings are very similar. It might change a little here and there, which we will be learning. So let us see the question. You are required to find out the number of workers falling within rupees 250 and 350. So rupees 250 and 350 is the wages of the people or the workers. So if you see here, earnings for daily workers. Up to 100, there are 50 workers. Up to 200, there are 150 workers. Up to 300, there are 300. Up to 400, there are 500. Up to 500, there are 600 workers. Now we have to find out the number of workers who are between 250 and 350. Okay, now let us start. The values, how you take, everything is same as the previous problem, because if you see this problem, it is again open-ended class interval. Up to 100 is nothing but less than 100. 0 to 100 will be up to 100. Then up to 200 means 100 to 200. So which is nothing but less than 100, less than 200, less than 300. Okay, so the problem will end up in the same type of solution. The only thing you have to realize is whenever they give less than, whenever they give up to, the way of solving the problem is same. I'll repeat it. The way of solving the problem is same. Now let us solve this together. Solve it along with me. So let us start. Solution. Now let us take the first part of x, another is as y. So x and y, and you have leading differences. Leading differences. Okay, now let's write x and y. Write it however it is given. So up to 100, up to 200, 300, 400, 500. Okay, up to up to up to up to. And since it's an open-end class interval, you have to write down the frequencies as it is, because it will be cumulative in nature. So it is already cumulative. So 50, 150, 300, 500, 600. Now coming to the leading difference. In this problem, I'm not writing the values completely. I'll just take the difference and write the difference value. So you, when you're writing in your classwork, write the differences for your reference. Okay. So the first leading difference is between 150 and 50. So 150 minus 50 will give you how much? 100. Next, 300 minus 150 is 150. 500 minus 300 is 200. 600 minus 500 is also, sorry, 100. This is not 200, this is 100. So that is your first leading difference. See, I'm being a little fast because we have already solved 2-3 problems. So I thought you'll be able to understand. Is it okay? Is it okay being this fast? Okay, good. Now the second leading difference will be between the next two numbers. 150 minus 100, this is 100, okay? It's not 160. 150 minus 100 will be 50. 200 minus 150 again will be 50. 100 minus 200 is minus 100. Next, third leading value, that is going to be 50 minus 50 is 0. 50 minus 100 is minus 150. Okay. Now, next, fourth leading difference, 0 minus 150 is minus 150. Now, if you want, you can write the note here also, like the previous question. Okay, where they have said that you're supposed to take the value of the frequency as it is. Now, find the x value. In this also, since they have given us 250 and 350, here what we will be doing is, we will have to calculate the values separately. For 250, separate x. For 350, separate x. Okay, that is the change when it comes to up to. So, calculation of value of x when x is 250. So if you see the question, they have told when it is 250 and 350. So we are supposed to consider x as 250 first. So number of workers earning 250, x is equal to 250 is the x to be interpolated minus what is the origin of x? Origin of x is 100. And what is the difference between the values? That is also 100. So origin of x is 100 divided by 100. So this will be 150 by 100, which is 0, 0, again 1.5 will be x. Now take the yx formula, that is y0 plus x into leading difference 1 plus x into x minus 1 into x minus 2, sorry, x into x minus 1 divided by 2 factorial into leading difference 2 plus x into x minus 1 into x minus 2 divided by 3 factorial into leading difference 3 plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into leading difference 4. Okay. Now I want you people to solve this here, this complete formula, put the values and solve it. Okay, and then I'm just going to say what is to be done for the next value also. So the next value will be calculation of value for x is equal to 350. Now calculation of value for x will be x is equal to 350 minus origin value is 100 divided by 100 will give you 250 by 100, which is 2.5. Okay. Now take this 2.5 and again find the value of x for the same formula, y0 plus x into leading difference 1. Everything will be same except x value. Okay, so plus x into x minus 1 divided by 2 factorial into leading difference 2 plus x into x minus 1 into x minus 1 into x minus 2 divided by 3 factorial into leading difference 3 plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into leading difference 4. Okay, so as per the calculation, you will get the y value here as 215.234 and y value here as 399.609. Now, what are we supposed to do with these values is that this is the important part. Listen carefully. So the calculation that you are supposed to do here at the end is number of workers earning less than 350. Less than 350 is the second value that we found out. This one. Okay, what is the value? 399.609. Okay, then number of workers earning less than, or you can just use a symbol, less than 250. That is the first value. That will be, see, 250 is here, 250 is here. So the value is 215.234. So 215.234. Now find the difference. Subtract these two. You will be getting 184.375. So this is the value, or this is the number of workers who are there between 350 or sorry 250 and 350. So therefore, number of workers earnings between 250 and 350 is 184 workers. Don't round it off here, because if you see after point it is less than 5. Okay, after point if it is more than 5 then you can round off. Since it is less than 5, we will keep it as 184 workers only. So whenever the question says up to and the question says 250 and 350, then you have to solve it separately. For 250 solve it separately, for 350 solve it separately, then subtract both the values. 350 minus 250 will give you the number of workers between the required asked value. Did you all understand? Is it clear? So will you do this calculations by yourself here? You just have to apply the values and calculate. Okay, so that I just didn't do that. Okay, so this completes your QABD 2 syllabus. We have covered all types of problems under this. Okay, now let's just revise this chapter particularly, because I want you to note few things in this chapter with the types of problems. So please understand, when it comes to Newton, especially, see, in the first method, I'm sure you'll be able to solve the Pascal triangle easily. Okay, in the Pascal triangle, every problem where you see you will have a missing data in between, or two missing data that can be given, or the data that has to be estimated later. Okay, so first take the first value as x, second value as y, and write down the data. Give the value starting from y0. Have the Pascal triangle. Never forget to assume zeros. If you don't assume zeros, you will get confused. You'll not be able to solve. So assume zeros and then start from 1. 0 plus 1, 1 plus 0. That is how you get the triangle. Okay. Later, just apply the values. Here, I hope you understood how to do it. Take the coefficients 1, 4, 6, 4, 1. So 1, 4,